On a summer afternoon in Los Angeles, the intense solar load bombarding a dark commercial roof drives surface temperatures to 150 degrees or more. This diagram illustrates the thermal gradient, the massive temperature difference creating downward pressure. That unyielding transfer breaches the roof deck, saturating top floors and transforming warehouse spaces into an oven. To fight that relentless thermal bombardment, rooftop HVAC units run continuously, turning the building into a massive, unavoidable financial drain. The standard industry defense against this heat intrusion relies on traditional rigid board insulation systems. But board systems carry an inherent physical flaw. They are pieced together. By design, they rely entirely on hundreds of joints, seams, and metal fasteners across the expanse of the roof. These structural gaps act as thermal bypass points where conductive heat slips past the barrier. Notice how the R-value graph plummets. These bypasses critically undermine the theoretical performance those boards provide on paper. Traditional piecemeal roofs fail because structural discontinuities allow heat to exploit the weakest links. The insulation material itself might be adequate, but the installation method guarantees it will be compromised. Spray polyurethane foam, or SPF, is a dynamic physical countermeasure that changes how the building envelope behaves. It is sprayed on site as a liquid that instantly reacts and aggressively molds itself to whatever it touches, whether that's an irregular substrate, an existing curb, or a complex parapet wall. As it cures, it forms a fully adhered, monolithic layer. It contains absolutely no joints, no seams, and requires no metal fasteners to hold it in place. This diagram reveals the foam's internal core. Millions of high-density closed cells filled with low-conductivity gas deliver exceptional resistance to heat transfer. And around penetrations like this roof vent, the seamless application entirely shuts down uncontrolled air movement and convective looping. By eliminating physical seams, SPF replaces a leaky patchwork of individual parts with a single continuous thermal barrier. The final defensive layer is a specialized, highly reflective elastomeric coating that is applied directly over the fully cured foam. This diagram shows solar reflectivity. The coating acts as a shield, bouncing solar radiation back into the atmosphere before it converts to heat. Simultaneously, thermal emittance actively sheds and radiates away the small fraction of heat the material does absorb. The measurable result of this dual-action surface is dramatic. The roof can remain over 50 degrees cooler than a conventional dark roof sitting directly next to it under the exact same weather conditions. By reflecting incoming energy away before it ever reaches the underlying insulation layer, the system drastically lowers the total thermal burden the building envelope must endure. That massive drop in surface temperature directly translates to a measured reduction in peak cooling demand of 11 to 27% for air-conditioned buildings. For the mechanical systems, this means shorter HVAC compressor cycles, the total elimination of midday thermal overshoot, and years of deferred equipment replacement costs. This performance is critical because of Title 24. Title 24 is California's stringent set of building energy efficiency standards, which legally mandates specific performance metrics for aged solar reflectance and thermal emittance. As this diagram illustrates, spray foam naturally exceeds these regulatory hurdles. It successfully combines continuous insulation, structural air sealing, and cool roof metrics into a single, unified application. SPF functions as a mathematically sound compliance asset, yielding verified energy savings through its combined thermal and reflective properties. There is one critical caveat. Every commercial property has a unique thermal fingerprint. The specific climate zone, the existing roof assembly, and the interior occupancy schedule all dictate how a roof will perform. Crucial variables like exact foam thickness targets and specific coating chemistries must be precisely calculated for the individual structure. They cannot be applied through generic one-size-fits-all formulas. Guessing these variables compromises your investment. A comprehensive on-site field evaluation is the only mathematically sound way to begin the project. Stop paying for wasted heat. Schedule a free roof assessment with Foam Roofing Los Angeles to map your exact Title 24 compliance path and quantify the long-term energy savings for your specific property.